All right, with the last section, we are going over direct variation and inverse variation. And the main thing you need to remember about direct variation and inverse variation is that direct variation is a ratio of y to x. And every time you take y and you divide it by x, you get the same amount, referred to as k. And if you wrote it as an equation, remember equations are y equals, then I just move the x to the other side by multiplying, and so my equation would be y equals kx. Very similar to y equals mx plus b, there's just no m. In inverse variation, then the relationship between y and x to get this k value is the product. And if I were to write this as an equation of y equals, then I would move the x over by dividing. And then this is how our whole rational function shape even works, is because we got x in the denominator. So because x is in the denominator, we get the shapes that we did in our first three problems with the graphs. So your job is to see, in these scenarios, is it direct? Is it inverse? Is it maybe neither? And again, one more thing about direct variation and inverse variation is direct variation, as x gets bigger, y gets bigger, and an inverse variation, as x gets bigger, y gets smaller. So if you're not sure, what's happening, make a little table. So you bought a bag of licorice that has 50 pieces and you're planning to share it with your friends. Let L represent the number of pieces of licorice and let P represent the number of people. So normally, we try to figure out what x and what y are. And x is your independent variable. We talked about that in the notes. And y is the dependent variable. So y depends on x. And in this situation, the number of pieces of licorice I get depends on the number of people. So right now I have a set amount of 50 pieces. And so if it's just me, I'm the only person, then I get 50 pieces of licorice. If there are two people, then we each get 25. For instance, if there are 5 people, we each get 10. If there are 10 people, we each get 5. And as I start to look at it, as x is getting bigger, y is getting smaller. And there is a constant that's happening here. Every time I take y and x and multiply them, because again, right now I think it's inverse variation since x is getting bigger and y is getting smaller. Every time I take my y and multiply it by my x, I always get the same set amount. I always get 50. So this is inverse variation. And now that I'm going to write the equation, when I write the equation, remember, it's got to be y equals. And the constant amount that we established earlier was 50. So I can write my equation as y equals 50 over x. I'll do 22, and then I'm going to leave 23 up to you. So determine if the table represents direct, inverse, or possibly neither. So what I want to first notice is, as x is getting bigger, my y's are getting smaller. So right now my first guess is yes, it's inverse variation. So now what I'm going to do to verify that is I'm going to check to see if the constant is a product of y and x. So when I multiply these, I get 24, and I multiply this, and I get 24, and then I multiply this, and all of a sudden I get 15. So this presented initially as inverse, but it actually ends up being neither. And the reason why I would say is because when it asks me to explain my reasoning, what made me realize that is that the product, of y times x didn't result in the same amount each time. And that's it. And I will let you guys handle the rest.